final exams. Look at number 11. Before I start, I want to tell you guys that we have quite a lot of questions. So I'm going to continue for about 15 minutes nonstop, and after that, you guys can have questions. So if you have questions during the interval, you can hold your question, and then after 15 minutes, you can go over it for about like 5 to 10 minutes. Okay? That sound good? Yeah. Right. So let's look at number 11. Question A. You have g of x. They give you a function g of x equal to cos x squared times log of 3 to sine sinh of x squared. Okay, and they tell you to find the derivative of this function. Is that better? Stop me if you can't see that thing. All right. So now we have to, first of all, we will look at this. We can go ahead and proceed our derivation, but we can sort of analyze it a little bit. So is this function even differentiable? Yes. When they give you something like this, it means that they give you x is all real. So with the interval x is all real, then for cos and sinh, it means that it all defined for cos and sinh function. So this function is differentiable everywhere. Therefore, you can proceed and find the derivative of g of x. Now we have a product right here. So find derivative will be using the product rule. Okay. So first, we can think of this as u and think of this as v. So what is u prime? You know from your hyperbolic session, this is sinh x squared, and since there's a function inside the parentheses, we have to account for that as well by using the chain rule. Okay, so we have to times 2x. All right, and we keep the second function. Right. All right. Since a product rule, we have the plus this function. What is the derivative of that? Now we have log base 3. We don't really have like a formal definition of the derivative of a log of something. So we have to somewhat transform that. So how do we do that? We can use the transformation kind of technique right here. That you have log 3 equal to ln sinh of x squared, okay, over ln of 3. Okay. This applies for a general case. What does that mean for a general case? For some general case, if you have log of a to some b, you can transform that as ln b over ln a. So that is your general transformation. Okay, you can go ahead. You can prove that, but since it's a pre-calculus course, or something that you should know already, so I won't be going over that. So that with that being said, so now we have to derive this function, right? Keep the same first function, cosine x squared, right? All right. So what is the derivative of ln sinh x squared? It's just the reciprocal of whatever the function inside, right? So we can rewrite this whole thing right here. We can say sinh x squared 2x times log of 3 sinh x squared plus ln 3 is just a constant. You can pull that outside. Okay, so ln, you know that ln u, some general k ln u, derivative is just 1 over u, right? Okay, so that will be 1 over sinh x squared. But since sinh x squared is a function itself, it's not like a x or u by itself, so we have to count that by using the chain rule. Okay, so we have to times the derivative of sinh x squared. What is the derivative of sinh x squared? Which is cosinh x squared times 2x. Okay. Now we can do some simplification. So you have 2x here. You have 2x here. You can pull the 2x out. Right? You can have sinh x squared times log 3 sinh x squared, okay, plus 1 over ln 3. Cosinh over sinh, what is that? That is cotangent, right? Cotangent, hyperbolic cotangent. Okay, so you can write all right.
What happened to our cosine? Hyperbolic cosine of h that was supposed to be at the end of the second term.
Which one?
So when we're finding g prime of x, and you were telling
this
us
one, right?
That right there, yeah.
Right. So now there's two ways that you can transform in this. All right. So let's rewrite that. So you have cosine, right? Cotangent, the hyperbolic cotangent, time cos x squared. Right. I didn't mean to skip that, but I should have add more step here. So now you have the same thing, right? Same thing. Plus 1 over ln 3. You can say so at first you have so let's say this. We'll look at this part only, okay? Which is what? Which is this part, which is ln 3 times over sinh x squared times cosine x squared times 2x. Okay. Now you have an identity. What does cos square x squared equal to? You can have that equal to sinh square x squared plus 1. Okay, that is your identity. You can use that and plug it in here. You have that means you have two answers. You'll be having two answers. Whichever way it works, that's fine. But this answer, I think, is sufficient enough. Okay, so that's your answer. This is your answer for A. Okay, so now let's go to B. B, you have g of x equal to inverse cosine sine of x. All right. E to the 3x. You can think of this, you can use the quotient rule for this because it's a function over a function, but you can think of it as a product function as well. You can think of it as a product. What does that mean? It means that you can write it like this. You can write it as inverse cosine sine x times 1 over 3x, which is what? Which is inverse cosine sine x times e to the minus 3x. Okay, so there you go. There you have a product right there. So therefore, the derivative of g of x would just be cos minus sinh x e minus 3x derivative. Okay. All right. So now we apply product rule. What is the we phi derivative of that function? What is that? You know that for a function inverse cosine u, the derivative of that will be equal to minus 1 over 1 minus u squared, right? So you can apply that right there. So you would have minus 1 over square root 1 minus u squared. U is sine x, right? So sine squared x, all right? But here you have a function inside parentheses, so you have to use the chain rule, which is cosine x, right? Times e to the minus 3, right? Plus this function. The derivative of this function is minus 3 e minus 3x times inverse cosine sine of x. Okay? Alright. So now we can do some simplification, right? So now we have minus cosine x over. You see, you have another trick here. And what is that trick? Isn't that sine squared x plus cosine squared x equal to 1, right? Therefore, this would equal to plus or minus cosine x, right? If cosine is 0, if cosine is negative, then it would turn out to be positive. We can write it so this is equivalent of writing absolute value of cosine x. Okay. All right. Okay. So, but they give you something. They give you the interval from pi over 2 to 3 pi over 2. Okay. So let's turn over here and continue. So we draw probably coordinates right like this. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. And we have something like this. We have a general rule. We have what does that mean? It means that in this quadrant, in this first quadrant, all trigonometric function are positive. Yes?
So much light of the sign that you're drawing out, so we can get mass changes.
Constantly track this. Okay. What does this mean on the second quadrant? It means that only the sine function is positive. And in the third quadrant, only the tangent function are positive. And in the fourth one, only cosine is positive. You can remember this as all student tech calculus. Okay? So that's how you can remember it. So now they give you an interval from pi over 2 to 3 pi